our first theme, like I said, is univariate and bivariate data, and I divided it into 4 or 5 topics. Again, this follows the Barron's Guide to taking the AP exam. And our first topic is all the different graphical displays. And we've talked about this in our after-school sessions already, but there are some reviews or some graphs up here. Which one of these graphs up here deals with qualitative data? I only see one that deals with qualitative data. Huh? Nope. Nope. Bar chart is the only one. Okay, bar chart is the only one that deals with qualitative data, categorical data. You can have blue eyes, brown eyes, green eyes, how many of each are in, and that's the height of your bar, right? That's qualitative data. That's a bar chart. It could be a pie chart as another way to display qualitative data. You could also do a contingency table would be another way to display qualitative data. But all of the others deal with quantitative data. A dot plot is much like we do with the NFL salaries. So that's going to be your dot plot. Each one of those salaries, each individual sticker represents one person. It is an actual dot plot. Histograms, how are they different from bar charts? Okay, the bars touch. I agree. What else? What's the difference between a histogram and a bar chart? How about the axes? Along the horizontal axis, what's true about a histogram? Frequencies are actually on the vertical axis. How about on the horizontal axis? What's true about a histogram? Bar chart's going to have the categories, isn't it? Green, blue, yellow, red, whatever. What's going to be true about the, you know? Yes, we create the bins, but what kind of units would I have? What's happening along those axes? Aren't they measurable? Right? So isn't it like it's a continuous axis? You have 1 inch, 2 inch, 3 inches, 4 inches, right? And you can go ahead and it's a measurable thing. Okay? So yes, histograms, the bars touch, and it's quantitative data. What's a cumulative frequency plot? It's another name for it. It's a fun word. Makes me want to think I want to dance. Ogive, right? So an ogive is the same thing as a cumulative frequency plot. I'm just going to kind of sketch one here. Do you remember what the shape's supposed to look like? It's not linear. It's actually sort of like an S, okay? And we are going to connect those, so it looks something along those lines. When we talk about ogives along the vertical axis, we have our cumulative frequencies. I'm going to make it go from 0 to 1. Okay, cumulative frequencies. And then, I don't know, we can just, whatever we want to measure, we can measure along this axis. We can measure anything, heights, weights, doesn't matter. How can I use a cumulative frequency plot to find an IQR? What is an IQR? In a quartile range. How do I find it? What's the formula for it? Good. Q3 minus Q1. How can I find the third quartile or the first quartile on an ogive? I'm looking for the percentage that goes along with it. Quartile 3 is 75%. What's quartile 1? 25%. So how do I find that on here? Well, I'm going to go to where 75% is, which is right about here. And I'm going to go out to my ogive, and I'm going to go down. And whatever number this happens to be, let's just make it a number. Let's say it's 400. That's going to be the number that represents the third quartile. I'm going to do the same thing for the first quartile. 25% looks like it's about here. Going to go out and go straight down. And whatever number happens to be here, let's just pretend it's 100. Let's make numbers up. What's the IQR? 300. 400 minus 100. And that would be the IQR. If you remember back when we did these types of questions early on, I said you could use the corner of your paper, where you can kind of line up your paper on 20. It's hard to do it on a smart board because it tries to erase it, but you can line it up and then just use your paper to go straight down, almost as a ruler, okay? And that's what you want to kind of use, that you have the paper accessible to you. So, okay. What's a stem plot? Stem and leaf. We learned about that back in middle school, probably even elementary school, I would think. And a stem plot, it's going to make numbers. Do I start with the large numbers or the small numbers? Small. That's important. Okay, so I'm just going to make some stems and then my leaves. I'm just going to kind of make some numbers up. No, let's do this. Made something up. Okay. What does a stem and leaf plot show us? It could show if we have multiple frequencies of things, because they would show up. Like you have 2 that shows up twice, right? 0, 2, I agree. What else does it show us? Shows shape. Which way do I have to turn my head to see the shape? Left or right? To the right. Okay, and it's going to show shape. What else does a stem plot show? What's this? It's a gap. Right? There's a gap in the data. So possible outliers, we're going to get to outlier tests in a little bit, but yes, it could be a possible outlier. There's something off by itself. That 40 is out there. I agree. So gaps, possible outliers, and shape. Are these plots used for large data sets or small data sets or both? Only small. Same with dot plots. Why? Dot plots and stem plots together are used for small data sets, and there's a reason why those two specifically. Histograms are used for large data sets. Why small only? What's special about dot plots and stem plots? Exactly. It shows individual data. I know that there is a 13 in my data set. I know that there is a 12 in my data set. When I look at histograms, I just know that there are so many between here and here, right? There's 50 in this particular bin. I don't know what they individually are. So large data sets, histograms, small data sets, stem plots, and dot plots. Good. Okay. And the important thing is they show shape. That's good. All right. Are we good? When we are asked to describe a data set by a graph, describe a graph, we're looking at what 3 things? Shape, center, spread, right? So shape, center, and spread. And you know what kind of vocabulary words go along with those things? What are some vocabulary words that go with center? What'd you say? Median. What else? Mean could use, yeah, How about spread? Standard deviation? Range, which I hate, but it always shows up. Yes, give me another one. No? Range, you said range and standard deviation. I can think of 2 more. IQR, means of center. Variance, okay? Those are all measures of spread, okay? And then what about shape? Give me some shape words. Unimodal, skewed left or skewed right. Don't say skewed by itself. Always attach a direction. What else? Symmetric, mound shape, bimodal, unimodal. I mean, there's so many shape words, right? Okay, good. So let's jump into our first question. Again, please make sure that you're changing this to A, B, C, or D, and E, actually. I have a rule of thumb when it comes to multiple choice questions. Multiple choice, for whatever reasons, tends to be the hardest portion of the exam because there are questions that jump out at you, that you think you're going to answer, you think it's easier, you get a false sense of security with multiple choice, but they tend to bring your grade down, okay? I'm just saying, they tend, historically. Now, some people are really good at multiple choice. I can think of a student in my second block class, excellent multiple choice taker, okay? Not me. I'm not good at it. I get like, ooh, maybe it could be this. I second guess myself all the time, okay? Here's some tips. One is if you can eliminate 2 answer choices, you're going to answer that question in the next 2 minutes, okay? So always try to eliminate answer choices. If you can't eliminate 2 answer choices and you don't know the answer, you're going to leave it blank until the last 5 minutes of the test. When you have 5 minutes to go, you're going to go back and you're going to bubble answers on your sheet. You do not get penalized for guessing, okay? They don't take points away. It's like the SAT, same thing. So if you can't make an educated guess and you're just literally just going to really guess, then you might as well bubble all B's or C's. By the way, those are probably the 2 best choices to pick, okay? I'm just telling you, I don't write the test, but historically over time, although I think one of these, E was a big answer. Yes? They don't know that you guessed. They used to, about 3 years ago, if you got a question wrong, they took off points. Now you're only getting points for correct answers. So that's why it doesn't hurt you. So if you guessed wrong, you would subtract points from your score. They no longer do that. Okay? So that's why it's to your benefit to answer every single question. Please listen for that 5-minute mark. If you're not finished, stop what you're doing and bubble in an answer for the first 40, all questions. Does that make sense? Please do that. That did not happen last year. People left questions blank. You don't know, maybe you get it right. You got a 20% chance of guessing it right, right? It's not a lot. It's not likely you're going to get them all right. Not likely that you get a lot of them right, but it's better than getting nothing, okay? So what's the rule? If you can eliminate 2, you're going to answer it right now. If you can't eliminate 2, you're going to wait till the last 5 minutes and guess, right? You should not spend more than 2 minutes on any one question. If you see that you're spending too long, try to eliminate answer choices and come back to it, okay? All right, I'm going to go ahead and pause this. I'd like for you to think about a strategy to answer this question because you actually have to do some work to answer it. It's not one that you can't do work for first. So I'll pause the recording. I would suggest calculator, so if you want to get that out and look at it from there. Byron just asked, and it was such a good question, I wanted to make sure all of us heard it. Why would sorting, because he asked, I forget how to sort on the calculator. Why would sorting in this instance be a good idea? Because in order to find the shape, you have to go from smallest to largest. It's kind of like putting it in a stem and leaf plot or putting it in a dot plot of some kind. You want to order it. If you don't order this data, it won't come up with the correct shape, okay, if you're going to create a dot plot or a stem plot. Okay. What kind of a shape? First of all, I'm going to look at my answer choices without even doing anything, and there is something I can eliminate right away. Which answer choice can I eliminate just by glancing at my scores? I can eliminate uniform. Why? What would the numbers have to look like in order for it to be uniform? It all has to be the same number. And since they're not, we can probably say we'd have the same amount of those numbers, not the same number. We'd have to have the same amount of them, right? We'd have to have four of each or whatever to be uniform, to have that uniform graph. And that's not what's happening. So I can probably eliminate that answer choice. So I'm going to cross it out. I am also going to eliminate A and E without even graphing. Why? Oh. Oh, is there? Yeah, whatever. It doesn't, not really. Why do you think I could eliminate A and E? They are parallel solutions, right? You can't be bell-shaped without being symmetric. Would you agree? So because of that, I'm probably going to eliminate those as well. If I'm just solely guessing, that's where I'm going with this. And so this is kind of a strategy I'm headed with. So I'm probably looking at a skewed situation. I believe that the graph, if you did a histogram, looks something like that. Is that true? I think there was a little bit of a gap. I can't remember. I hate the calculator's histogram, by the way. It never comes out exactly like it's supposed to. But would you, to the best guess that we could do, wouldn't you agree that the tail is to the left-hand side? Okay? And so that's where the skewness lies. So the best answer here would be skewed left. Okay? Any questions about descriptors of shape? Okay. All right. This one again, Roman numeral 1, 2, and 3. So please make sure you change those accordingly. And let's answer these. Talks about stem plots. We have answered this question already. See if you can answer it here in a few minutes. I see only one fully correct answer. So let's go through each Roman numeral and highlight the issues. What is the issue with Roman numeral 1? Right, categorical. We know that's not true. So we're going to say that's our issue. So it's not Roman numeral 1. What's the issue with Roman numeral 2? Large data sets, right? That's not true either. Do stem plots show symmetry, gaps, clusters, and outliers? Yeah, so it does show those shapes. So the only correct answer would be C. Okay? Good. All right, same type of format. And again, this formatting has really changed for questions that they ask. But what is important is the content of the material. So we'll keep that. I was also emailed today an online practice for us. So we're going to start looking at that later in the week, which will be kind of fun. Okay? And don't forget to bring your plicker. Remember that thing that I gave you to put in your formula sheet? We're going to start using that again on Wednesday as well. Okay? Better than this, right? Make it more interesting. Rotate your picture. All right. Let's look at this question. Now, none of the above scares me for some reason, because I always think I want to pick it, because why would they have it on there if it wasn't there? That's not always true. So don't be swayed by none of the above. Just saying. Sometimes you use it, sometimes you don't. But it doesn't mean you should pick it because it's there. Okay? The word all is usually a clue that there's an exception to that rule. Okay? So all symmetric histograms have single peaks. True? Can you imagine drawing a symmetric histogram that doesn't have a single peak? That one's symmetric? 2 peaks, bimodal? It's symmetric, but does not a single peak. So because of the single peak, we know we can cross that one out. Notice, if I can only eliminate this one, I can cross out everything with a 1. Would you agree? I've eliminated 2 answer choices. That means I'm going to answer this question right now. What about number 2? Number 2 and Roman numeral 3 are kind of like, well, they're not the same. Think about geometry. Aren't they inverses of each other? Or they're, no, they're not inverses. The converses of each other? Right. If it's symmetric, then it's normal. If it's normal, then it's symmetric. Which one's true? Well, only one can be, because the word all is in there. Are all symmetric curves bell-shaped? Are all bell-shaped curves normal? You know of a distribution that's bell-shaped that's not normal. The T. Isn't the T distribution unimodal and symmetric? It's not normal. It gets close to normal when your degree of freedom gets really large, but if you have a small degree of freedom, it's not normal. So that can't be true either. So only Roman numeral 3 is the correct answer. If it is normal, it's definitely bell-shaped and symmetric. Okay, good. I'm going to pause this in just a minute because there are some words up here I don't think you remember. I have a feeling, a hunch. So I'm going to call on you in a couple of minutes. I want you to make sure you understand each of these words. You can use your book. You can use each other. Come up with your own definition. Make sure how do they relate to one another? That kind of thing. For example, mean and median. When do you use which? If one's bigger than the other, what does that mean? Okay, those are the kinds of questions I'm going to ask you. So I'm going to pause the recording. I want you to kind of look at your book. If you need to borrow a book, they're on the bottom shelf. But come up to some answers and make sure you can answer questions about all these topics. All right, so let's start with median and mean. When do I use which, and what do they use to describe? Let's start with Ayana. What do they use to describe? The center. Very good. So they're measures of center. When do I use the median as opposed to when do I use the mean? What do you think, Maria? I use one in one situation and another in another situation. When I'm looking at the graphs, I am looking at graphs, but more specifically, what characteristic of the graph am I looking at? Looking at the shape, okay? So one of them is used when the shape is skewed, and one of them is used when the shape is symmetric. Does that answer your question? All right, so let's answer it. Which one do I use when it's skewed? Median, good. Because the median is resistant to outliers. It doesn't move as much. So you're going to use this, using the highlighter there. You're going to use the median when you have skewed data set to describe the center, and you're going to use the mean when you have a symmetric. Okay, but they both talk about measures of center. What happens if I don't have a graph like Maria suggested, but I'm just given values, and I know that the median value is bigger than the mean value? What information does that provide? I don't have a picture, I don't have a graph, but I can still describe shape. What would the shape of when the median is bigger than the mean be? Skewed which way? Okay, I like to draw a picture. Let's see if you're right. So if I had, you said skewed right? So I'm going to draw a skewed right graph. Okay, just kind of get the idea. Definitely skewed right. The mean is always pulled in the direction of the tail. Wouldn't you agree? So the mean is going to be more down here. And the median is not as resistant. So it's going to be back here, closer to where the actual middle, it's a placement, the middle placement, not the average. So which one's bigger in this particular scenario, the mean or the median? Try again. The mean is bigger. The further right it is, the bigger numbers are on the right, correct? So a skewed right situation would actually be this. Whoa, would actually be this. Wouldn't you agree? This would happen when it's skewed right. What would be true if it was skewed left? It would be the other way around. The median would be larger. Okay? What would the shape be if they were about the same? That would be a symmetric situation. Okay? Important information to know, because sometimes we aren't given a picture or a graph, but we can still describe shape, center, spread based on what they tell us, because I can compare those two values. Okay? Spread. I've got all the measures of spread listed up there. What's the range? Karen, what's the range? Yeah, just a large, and it's really not a very useful thing. We don't use it that much. It does appear on the AP exam, though, so you have to know what it is. IQR we've already talked about. When is variance used? We know it's the square of the standard deviation. We know that's the relationship. But there's one instance that I can think of where you have to work with the variances. You can't work with anything else. When is that? Hello. Hi. From me? Wow. Oh, thank you. Leaking everywhere. When is variance used? One situation. When does that happen? If I say the words combining random variables, does that mean anything? If I have a box of weights, I don't know, and I need to figure out the total weight of the box, but I've got the actual bars in the box and I've got the box itself. The box itself is going to have its own mean and standard deviation, and then each of the bars are going to have their own mean and standard deviation. So I've got to combine them. Remember, you have to work with the variances. Remember, you always add variances. You never subtract them. This all hopefully sounds familiar. If it doesn't, then you need to make sure you go and review that topic. If I remember, well, I know I remember, but if you remember, there's a lot of formulas associated with that, okay? And they're not on the formula sheet. So later on in the week, we'll be looking at that again, okay? And looking at those combining random variables again. But that's really when you use variances and really the only time I can think of. In our online teacher forum for AP Stats, percentile ranking came up as a topic of conversation this weekend. I know that sounds thrilling to all of you. Y'all were at prom. I was online talking about math. Yay. What is that? Like, here's an example. I was just reading a U.S. News and World Report thing that said that Osborne Park High School, which is where my kids go, was in the top 3% of high schools in the country. It's actually the top-rated Prince William County school because of their AP scores and IB scores. It's the most academically challenging school in the county, which I find interesting. But top 3%. Does that mean their percentile ranking is 3%? What would their percentile rank be? 97%. So percentile rank is you are better than that many or that percent of people. So if you're in the top 3%, your percentile rank is actually 97%. Okay? So kind of keep that in the back of your mind. Z-score. What is that? And don't give me a formula. We know what the formula is. Give it to me in this position. What does it relate to? Here. Yes, that's exactly what it is. It's the number of standard deviations away from the mean. They always ask questions about, is something unusual? Okay, is a value unusual? What would be an unusual z-score? Larger than 3 or smaller than -3, okay? Those would be unusual because of the empirical rule, actually. So if you see the word, is this an unusual score, that means you should probably find the z-score and decide if it's greater than 3 or less than -3. Okay, that'll help you make that decision. So unusual, look at the z-score. Okay, that's a key word, unusual. What is the empirical rule? This is one I didn't think many of us would remember the percentages. Oh, goodness gracious. Let's see if you do. Who wants to take a guess? Anyone want to try? Someone besides Katie. Who wants to take a stab at it? Cameron, go ahead. And what was the last one? Yes, very good. When you have a normal distribution, you can have one standard deviation above and one standard deviation below, and you have 68% of the data. Within 2 standard deviations, you're going to have 95%, and then within 3 standard deviations, you're going to have 99.7. And that is why anything above a 3 z-score and below, because the z-score is the number of standard deviations, so anything above a 3 or less than 3, or less than -3, you're in the 0.3%. And actually, it's 0.015% because you're dividing it by 2. Crazy. Okay? So it's really unlikely that that happens. It can happen, but it's just not very likely. It's unusual. Okay, good. We talked a lot about the cumulative frequency, box plot. Oh, we haven't talked about box plots. We're going to in a couple minutes, okay? We know that stem plots, you turn your head right, it'll show skew. Histograms show skew. How do box plots show it? If I had a box plot, is that skewed? The tails are the same length. Would you agree? The whiskers, they're the same. So the whiskers don't show skew, but what does? Where the median is in the box. You know that right here is still 25% of all the data. So if I have a really short piece to my box, what would that look like in a histogram? A really tall bar, okay? There's a lot of things right between here and here because it's small. The longer box means it's more like skewed. So what would I say this is probably skewed? Right, would be what I would be talking about. So sometimes the box shows skew, sometimes the whiskers show skew, okay? You can have a long whisker, and that happens too. Good. All right, let's jump into it. I'm going to go ahead and pause this. I want you to try this one on your own. I'd like for you to use it on the calculator or do some work on the calculator. And I also want you to answer the question, is Ricky Henderson an outlier? Okay, so I'm going to pause this for a minute. And I want you to mathematically show me whether or not he was or was not an outlier. Let's see how much we remember. The way I have put it in my calculator is not how most of us put it in our calculators when I walked around and saw. Okay? Tell me, most of you put 0 in 10 times and 1 in 8 times. Totally okay with me. You'll get the same answer. Doesn't matter. But I wanted to show you this way. What am I doing here? What is this called? I'm using the frequencies. It's a frequency distribution. So in list 1 is the number of hits, and then in list 2 is the frequency at which they happened. So if I go to stat calc and I do my one variable statistics, I have to put list 2 as my not Z, list 2. Why is it doing alpha? There we go. List 2 is my frequency, and then I can calculate. Okay, you should get the same answer either way. Just kind of a little bit of a shortcut. So you don't have to like press 0, make sure you didn't miss one, and you actually pressed it 10 times and whatnot. Just food for thought. What am I looking for here? I'm looking for the mean and the median. What's the mean? 0.579, which is about 11 out of whatever it was, 19? 11 out of 19. So I know that the answer is either A or B. Where do I go on my calculator to find the median? Maddie, where do I go? How do I find the median here? Yeah, just keep scrolling, and there's my median. Median 0. Okay, that's good enough. Perfect. So I know that my answer is going to be A. How do I tell whether or not Ricky is an outlier? Let's see if we remember the formula. Remember the formula? Mr. B student first semester? Come on, do you remember? Okay, he graphed it. Perfectly okay if it's a multiple choice question, wouldn't you agree? If I graphed this data and did a box and whisker plot, wouldn't the outlier show up as a dot? That's a quick way to answer that question. That's actually brilliant. Okay, very good. If I wanted you to show the work, how would I do it that way then? Yes, box and whisker plot, and it actually shows up as an outlier, doesn't it? Yeah, so we know it is an outlier. Here's the formula in case you forgot. You take 1.5 and you multiply it times your IQR. You're going to add that to Q3 to get your upper fence, and you're going to subtract it from Q1 to get your lower fence. The IQR is Q3 minus Q1, which I believe is 2 minus 1. So the IQR is 1. So our upper fence is going to be 2 plus 1.5, I'm a liar, 1 plus 1.5 times 1, which is 2.5. That's my upper fence. My lower fence is going to be 1 minus 1. Actually, was quartile 1, 1 or 0? 0, wasn't it? So it's 1 minus 0. Not 2 minus 1. Sorry about that. Okay. So it is going to be 1 minus 1.5 times 1, or negative 0.5 as the IQR. Would you agree with that? Now, as the lower fence, nobody's going to have negative hits. I get that. Okay? That's just a fence. Yes? Oh, 0. I'm sorry. Yes, because quartile 1 was 0. Thank you. So it's negative 1.5, which makes even less sense. But yes, they're going to have a negative number of hits. But that is the lower fence. You're right. Is Ricky an outlier? Why? Because it's larger than 2.5. He got 3 hits, right? So because of that, he is an outlier. And Josh was right. It showed up on his calculator that way too. So the answer would be yes. Okay? Either way, we'll get to the same answer. Good. Excellent. All right, let's keep going. Again, we have Roman numerals 1, 2, and 3. If you would kindly change those for me. Let's see if we can't figure out the answer here. Wrong. What's wrong with, there's one word in there that's wrong with Roman numeral 2. Half, right? Half, wake up. Half is the issue. We know it's Q3 minus Q1. It's not half of it, right? So half is the issue. So we can cross off that. That means that I can eliminate anything with a 2. I've eliminated 2 answers. Guess I'm going to answer this one. Okay? So, how about number 1? True or false? It says we're looking for true statements. Is number 1 true? It is true. Let me tell you why. The population is everybody. Samples are within that population. You can't have a sample that's bigger than the population. Doesn't make sense. The population it's everyone, right? So the range for the population is always bigger than a sample, okay? It might be the same, right? It might be exact. If you happen to get the first and last numbers in my sample, it could be, but it's never greater. Would you agree? So that's true. How about Roman numeral 3? Is that one true? Is the range affected by outliers? Sure, because it's largest minus smallest, whether it's an outlier or not. So it is. Is IQR? No. Remember, it's resistant. It's quartiles. It's position. So both of those are correct. Okay? Good. This question here goes back to the first week of school, back in September, right before Labor Day. First week of school we answered this question, or this type of question. My question to you is, if I increase by 25%, what am I doing? Am I adding, subtracting, multiplying, or dividing? Multiplying. What am I multiplying by? What number would it be? 1.25. Okay? So increase by 25% means I'm multiplying by 1.25. When I multiply, which things are affected? Your median, your mean, your standard deviation, your range, your variance, your IQR. What are things that are affected if I multiply by 1.25? Everything. Remember the visual that we did back in September? We had a number line with people had the little dry erase boards, right? And I said, okay, pick a number line, get in order, and everybody add the same number. What did that whole group do? They all stayed the same spread, but they just shifted, which means the center shifted. But the spread didn't change. Went back. If I had you guys multiply, didn't the whole thing change? The spread changed, everything changed. So when you multiply, everything changes. So doesn't that mean that I can eliminate anything that has an original number? Would you agree? Guess I'm going to answer this question right away. Which one is it? It's E, because they just multiply both the mean and standard deviation by that 1.25. Good. Awesome. If you are increasing, you add it to 1. So you're adding 25% or 0.25 to 1. If it was decreasing, you'd subtract it from 1. So if it was decreasing by 25%, it would be 0.75 that I'd multiply by. Good question. Did you learn something today? Perfect. Okay, good. All right, let's go. Let's try not to move my smartboard here. There's that none of the above again. I give it the stank eye. I'm not sure I like that none of the above. I'm going to have you answer this one for me since you keep dozing off. Okay? So read it to yourself. It's telling us we have multiple gaps and clusters, which means whatever we choose as an answer, the gaps and clusters must show up. So based on that, can you eliminate any answer choices? First two, right? I mean, our gaps in first three, really. I mean, are gaps and clusters going to show up if I just give you a couple numbers? No. A box plot doesn't show gaps and clusters. It just shows long whiskers or short little boxes. Byron, what's the correct answer here? Yeah, the stem plot or a histogram, either one are going to show gaps in data, and they'll show if things are clustered together. I agree. So that none of the above, just sitting there. Good. All right. This should be a quick answer. And again, none of the above. There it is. The standard deviation is almost never 0. Okay? It'd be a very rare thing for it to be 0. And it only happens in one instance. April, what do you think? When would that one thing happen if the standard deviation was 0? Yeah, if all the observations are the same. If there is no variance among the data, then there is no standard, the standard deviation would be 0. That's exactly right. Okay, good. Good, good, good. Okay. I'm not going to draw these graphs, but what I am going to do, I'm going to come back to, I'm going to draw a graph in a minute. Topic 3. This is the only graph we haven't talked about yet today. I want to answer one question about it quickly. We're running out of time here. We've got 15 minutes left. They did? Like this? I'm going to do one. Yeah, the vertical ones, in my opinion, are harder, but you just have to in your head. She's going to mail me your test. What's a parallel box plot? 2 or more. You could have 3, 4. You could have a lot of box plots. But what's important is that they're on the same axis. Okay? Same values. And you use them to compare. We want to compare their medians, compare their spreads. And so in order to compare them, they have to be on the same scale. Okay? So that is something. What's another graph up here that would be used for comparison? There's only one other. Back-to-back stem plots. So both of these are for comparing. Okay? Back-to-back, you can only do 2 distributions. Parallel, you can do multiple. I'd like to look at one here and change this word to median. And I'm going to draw a couple of box plots. By the way, this depends on the version of the Barron's Guide, so it doesn't really matter. But let me draw the box plots and see if you can answer. Fernando, would you just pop that out for me real quick? Yeah, that's the one. Thank you, Dave. How many times has that happened? Like 3 times so far today? Awesome. Okay. Okay, so there's your two box plots. I should include a title for each. I should include scale, but we're really just trying to decide not what is the median or what is the range, but whether or not they have the same one, okay? So we're going to assume they're on the same scale here. Do they have the same median? Where do I look to compare them? Which line? There's lots of lines. One in the center of the box, the inside of the box. Which one is bigger? The one on the left, because it's higher. Good job. Okay. So we are, in fact, looking here to decide whether or not the medians are the same. And they're not the same. So we can cross that one out. Okay. Same range. True or false? Regular range. It would have to say interquartile range if it was, okay? So if it just is range, it means min minus max. To me, it looks like they are, okay? It's not, I mean, I didn't draw it exact or perfect, but you're really looking here at these, this minus this is really the same as this minus this. It's pretty darn close, wouldn't you say? So to me, I would say that's probably correct, okay? Pretend I drew it right, okay? What about the variance? That's a harder question, I think. Maybe not. Yes or no? What am I looking for on the graph? I can't look, I don't know what the standard deviation is on a graph. What does the variance measure? Shape, center, or spread? Spread. When I'm talking about spread, what am I looking for? The box. Would you agree with that? Which one has, do they have the same size box? Definitely not. So do they have the same variance? No. Which one has a bigger spread? The one on the right. Yes. And that's a perfect thing to do is look through your answer choices and then work backwards. I'm not, yes, absolutely. If you're stuck especially, and Fernando, what happened again? Oh my gosh. Sorry. Thank you, baby. All right, so the answer would be only Roman numeral 2. So the answer is B. Okay, good. We're just going to kind of skip through. I wanted to, before we end the day, kind of, because you are going to finish all these questions for homework. This is going to be part of our review, and so you need to finish the rest of these questions and bring them with you on Wednesday. But I wanted to make sure before I send you off that we talked at least about bivariate data, because that's what this is. Whenever we're trying to ask ourselves a question, is the data linear? What questions are we asking ourselves? Or what am I looking at? What kind of plots would I be looking at if I was saying, is the data linear? Give me one of the plots I would use. Scatter plot. And what am I going to be looking at for the scatter plot? Not the residuals. If it's linear or not, right? We're going to look at the scatter plot. Does it look like it's relatively straight? Okay, so you're going to be looking at whether it's linear. What else am I going to be looking at to answer this question? Residual plot. With the residual plot, what am I looking for? No pattern. On Wednesday, we will look at how to, on the calculator as a review, how do I create a residual plot? Do you remember? Okay. What else do I want to look at to answer the question? If I say the thing that we need to look at strength, whether or not it's very linear, a little bit linear, not so linear, when I say strength, what do I look at for that? The R, what is that called? Correlation. Good. What should, if it's going to be strong, what would R have to be close to? Or -1, right? So R is approximately plus or minus 1 if it's strong. What am I missing between strength, the shape, the strength? I also need to include the negative or positive, which tells me direction, right? So you need to have direction also. which means it's either positive or it's negative. Okay? That implies direction. All right, so I'm going to stop the recording. This is for you to finish. This theme 1 is just covering univariate and bivariate data and describing distributions and things like that. Okay?